Very good evening to all of you, and a very warm welcome to Baiju's exam prep IS. Good evening, good evening, very good evening. Please, 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 hurry up. Come in, come in. Ram Ram ji. Good evening, good evening. Come on, come on. Hurry up, hurry up. Let's fight for your bright future. All right. I'm good, Tarun. How are you doing? Hello. Only today, Kishore? Same to you. Sat Shri Akal ji, Vrinder ji. I'm good, Jayashree. How are you doing? Come on, hurry up, guys. Vanakkam. I'm good, Vishal. How are you doing? I'm good, Bithun. आप कैसे हैं? How are you doing? చాలా బాగుంది. Shravani. బాగున్నారు. Thank you, Jayashree. I'm good, Lakshmi. How are you doing? No, I don't know all languages. Not very fluent, but yes. Kunchum ustundi. Jai Shri Krishna ji, Jai Shri Krishna. Very good evening. I'm good, Nikita. How are you doing? Yes, Ashwini, they would suffice provided you practice, revise, and practice from the books that I have suggested. Kannada, I don't know much. I only know Madi. That's it. This Madi, that Madi. Not many, Vivek. Tidbits, roaming about all over India, all over the country. So I just catch hold of a few, uh, working statements. Yes, it is my favorite too. Jai Balaji. Thoda, Famina. I'm good, Simran. All right, then let's start. Come on, warriors. Thank you, Snehalata. Thank you. I'm from Delhi. Atharv. Chalo, let's start. In yesterday's session, if you remember, we were left with three questions. In fact, we are done with these topics as far as things go. Only three questions remaining, so we will take this up. And then today's syllogism. And then on Monday, we will take up calendars and clocks. And then the last class shall be for these four. That would be the last class for reasoning. All right. And then we will start with mathematics. Har Mahadev. All right. Let's do it. Come on, guys. So questions from previous years pertaining to blood relations. That's what we were discussing yesterday. CSAT 2022. Now, how you should be solving such questions. PQRSTU are six members of a family. The moment you read a statement, your pen should start working. You should start scribbling in your register. All right. So we have PQRSTU. All right, sir. R is the spouse of Q. Okay, let's convert this in some kind of a symbolic notation. Okay, wherein R is the spouse of Q. So spouse means we don't know whether R is husband or wife. U is the mother of T and S is the daughter of U. All right. So U here is the mother of T and S here is the daughter of U. So U here is mother of S and T, and mind you, the gender of T is not known. S here is a female. U here is also a female. Okay. Now P's daughter is T. Here we go. Then P's daughter is T. So now we know the gender of T has to be a female because she is a daughter. And also now we know that U and P here must be spouse of each other. This shall be wife. This has to be the husband. Correct? And P here must be father of S and T. R's son is P. Oh ho ho. So here I go. We have something here. So R's son is P, who's a male, correct? And as it is, we know that R and Q are spouse. Gender of R is not known. Gender of Q is not known. P definitely is a male. T is a female. S is a female. F is a female. Nothing else is given as far as the relations go. But then there are two couples in the family. Which one of the following is correct? Now, which are these two couples? Obviously, one is Q and R, and the other is U and P. These are the two couples. So the arrangement is very much here. Okay. No, Shravani, you don't need to do all these things. Represent female in a circle, male in a square box. Why? Why? Why can't I simply write M? M stands for male. See, all those gimmicks, all those are gimmicks. You know, put plus for male, minus for female. I mean, I particularly object putting minus for females. Why? Why negative symbol? First thing. Second is, no, that's what I'm telling you, Vivek. Is equal to plus, is equal to minus. Why? Why do you want to change the notations? Why do you want to, have another system? And then you have to remember that as well. What's the requirement? That's the point. Can't you simply represent a male by the letter M, a female by letter F? Damn simple, Ray. We are just complicating things so that something can be taught to you as a system. Array, not required, Baba. Use common sense. Right? All right. So here Q is the grandfather of T. We do not know the gender of Q. Gender unknown. Q is the grandmother of T. Can't say because Q's gender is not known. R is the mother of P. Well, again, gender is unknown as far as R goes, but yes, T is the granddaughter of Q. Absolutely correct. That will work out. T here is the granddaughter of Q. Okay. And as it is, there are two generations, gap of two generations. All right. So you go down two generations down, grandchildren, two generations up, above, the world so high. So then we have grandparents. So a very simple question, I would say, CSAT 2022. Just 2 years back, I would say. All right, sir. CSAT 2022. Another question came. I'll give a poll for this. It's a very, very commonsensical question. Come on, come on, come on. Please hurry up. Officers are joining 9 minutes, 10 minutes late. Want to be an IS, IPS? How would you tell your juniors to come on time? Come on, guys. Hurry up. Mark your answers in the poll. Femina, check. No, not done. For some people, yes, Monica. Others, no. Sai Dinesh, check. Vivek, check, 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 check. See, only 21% could get it correct. Wow. X is a brother of Y. So this is X, this is Y. X is certainly brother of Y. Y is brother of Z. So Y is brother of Z. So genders are known, male, male. The gender of Z is not known. I mean, Y is brother of Z. Z could be Y's sister or brother. Can't say. So the question is Z brother of X? So statement 1 alone is definitely not sufficient, sir. Statement 2 alone says X, Y, and Z are siblings. So they are brothers and sisters. So is Z brother of X? Again, gender unknown. So 2 alone is not sufficient. Even if you combine both, then also the gender of Z is unknown. So D becomes the answer. Poll, yes. Poll had appeared. Harsh. Correct, Kamal Pal. Yes, Kamlesh. Correct. All righty then. Here we go. So fresh. CSAT 2023. Let's see. I'll just help you out. No poll for this. There are 5 members, A, B, C, D, E in a family. What is the relation of E to B? So always keep in your mind what is it exactly that you need to find out. Relation of E with B. Now there is only one statement involving B. All right. A and B are married couple. Okay. So A and B are married to each other. So they are spouse of each other. Who's male, who's female, we don't know. Anyhow, we need to find out the relation of E to B, so we require E's gender. Anyhow. Second statement is D is father of C. Take it somewhere else. D is father of C. E is D's son. Okay. Now, first 3 statements, obviously, I'm not able to find out what is the relation between E and B. Right? There has to be some attachment here. All right. So A and C are sisters. Here we go. So A and C are sisters. All right. C's brother must be E. Why? Because E here is son of D. So D here is, it's given D is father of E, C, and A. Okay. So how is E related to B? Well, how is E related to B? Can we find out? You don't need to find out the relation. But can you find out how is E related to B with these statements all required at the same time? Yes, sir, correct. All 4 statements. Sorry, my bad. So all 4 statements together are sufficient. So as it is, E here must be the brother-in-law. Absolutely. Yes. So such a simple question appeared in CSAT 2023. See, reasoning is going to be your life savior. I'm telling you, 80 to 90% of the questions in reasoning should be solved. You must attempt, if 13 questions came in 2023, you should have attempted 10 to 11. If 17 questions appeared in 2022, you should have appeared in at least 14 to 15. All right. And you would solve them and get your answers correct, not less than 80% of your efficiency or strike rate or accuracy. So no worries. Okay. So that was that. Now coming on to what we people waited for. Option B is also correct. No, sir. S1, S3, S4 are sufficient. Let's try. S1, A and B are married couple. So spouse. 2 you are not considering. Okay. E is D's son. So E is D's son. A and C are sisters. A and C are sisters. Now, how do you connect it? You need a connector here, right? How will you connect it with this arrangement? This is between A, B, and C. This is between D and E. 2 independent arrangements. So to connect them together, we have a statement, and that is D is father of C. That is very much required. Then only you will be able to connect them all. So B would certainly be incorrect. Okay. All right, sir. Let's begin with. You're welcome, Chituri. Now, let's begin with syllogism. Okay. Types of questions are asked in one statement, two statements, three statements, four statements, and we would be solving questions based on three statements, even four statements if required. Ways of solving, there are two methods. Actually, the name of the topic is logical deductions. And syllogism is just one of the methods of solving questions based on logical deductions. Is not pertaining to reduction or subtraction. It is all about to deduce something, to analyze, to come to a conclusion, to take a decision. All right. So ways of solving, there are two methods: Venn diagrams and another one which is called syllogism, but I call it the tick cross method. Okay. So here, uh, I would explain both the methods to you. First, we will learn Venn diagrams. All right, but Venn diagrams, as you know, are pictorial graphical representation of sets, diagrammatic representation of sets, all right, using geometrical figures. Now, any question that comes based on logical reductions, if at all there are two statements given to you, let us say, you have to draw each and every single Venn diagram for those two statements. Let us say you have two statements like all A are B, all B are C. Now you have to draw every Venn diagram wherein all A will be B, every Venn diagram where all B will be C. So you have to consider every case. Okay. And then the conclusion that you draw from the two statements has to be true in every single case. It has to be true in every single Venn diagram. That means if you have skipped or missed any Venn diagram, right, which actually violates or invalidates the conclusion that you have drawn, in that case, you have jumped onto a wrong conclusion. So, conclusion is always true in all the cases. If a statement is true in one case and false in another, it does not become a conclusion. It is called a possibility. May or may not be true. But a conclusion is that statement which must be true in each and every single case. Okay? All right, sir. So, as every language has its own grammar, so similarly, the language of deductions also has their own grammar, in which a statement like all A are B, if I just break it up, all here is called a quantifier. A is called the subject term, B is called the predicate term. You need not worry about the subject term or predicate term. Just remember them as first term and second term. That's it. Nothing else. So, what is a quantifier? What is the meaning of the word quantifier? Quantifier, 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 quantity. Huh? All right. So, a quantifier is any term which specifies a quantity. How many A's are B? All A's are B. How many A's are B? Some A are B. How many A's are B? No A is B. How many A's are B? Some A are not B. So a quantifier will tell you the quantity of subject term or the first term in relation or with respect to the quantity of the second term. All right. So that's very important for you to understand. Correct. Measurable. So it's a measure. Okay. So as I said, there are four quantifiers, all no, some not, and you must remember them in the same sequence also. Okay. All, no, some, and some not. Okay, these are four quantifiers. Now let us try to understand each of the quantifiers and the Venn diagrams which would represent them. So mostly if I give you this question, and you decide to solve this question with the help of Venn diagrams, you would draw only one Venn diagram. Now that is where your attempt will go for a toss. Okay. So as I said, you must consider all the cases in which all A are B, all B are C. So let's have a look at the Venn diagrams. All A are B. Let's first have a look at this. All A are B. Okay. So am I okay with it if are you okay with it if I draw this diagram to represent it? Is this visible? Is this visible? This circle in black? Or should I? All right. All right. It is visible, but better if I use white color, right? All A are B. So as it is, I am going to conduct the poll wherein we will interact with each other. A means yes, B means no. So do you agree with me? Do you agree with me? Can I represent it like this? Can I represent it like this? Fill in the poll, please. Fill in the poll, please. 95%. Lovely. But how if I take this particular case? This case where A equals to B. Can I say all A or B? Can I use this case or this diagram to represent all A or B? Even here, all A or B? I suppose so. Yes? Tell me. Do you agree? Do you agree? There would definitely be some disagreements, I believe. No, Anushka. No. 69%. Oh my God. Why is it that you don't agree? Can you show me a single A which is not in B? When you say all A are B, it means that the circle which represents set A must be inside the circle which represents set B. It means that set A is a subset of set B. True? It means that the circle of set A, no part of circle A should be outside circle B. True? So don't you think that even when A and B are equal to each other, A is a subset of B? Is there any part of circle A which is outside circle B? Tell me. Got it? No, might not be is a different thing. Saurabh. It might be. So I'm taking all the cases. Maybe A is inside B, maybe A is equal to B. All right, guys. Now you listen to me. Whenever you're solving questions which are based on deductions, logical deductions, using Venn diagrams, you must draw two Venn diagrams. You must draw at least two Venn diagrams. Which ones? One with least intersection between the two sets, and the other with maximum intersection between the two sets. Least intersection, maximum intersection. Least intersection, maximum intersection. All right. So simply A here, when you say all A are B, it simply means that A is either less than or equal to B. That's it. It cannot be greater than B. Are we clear? Yeah, B may be bigger. Very true. But B may be equal also. We don't know. But one thing for sure, that A is either less than B or equal to B, but A cannot be greater than B. So please make sure that whenever you're drawing Venn diagrams for all A or B, then these two diagrams should be drawn. Both. Please know this. Okay. Is that clear? B are not A. No, Femina, I didn't say that. B could be. All the B's could be A. Maybe some of the B's are not A. Can't say. Because the statement is not about the quantity of B which is A. The statement is declaring that all A are B. It is giving you information about set A. All the members of set A are in B. Am I wrong if I say all dogs are dogs? All dogs are dogs. What's it? What, right? Correct. So they may be equal. First term is dog and the second term is also dog. And then the first case is all dogs are animals, but all animals are not dogs. Okay. So you just need to know one thing for sure, and that is whenever you're drawing Venn diagrams, you must draw two Venn diagrams, one with least intersection, the other is with maximum intersection. And these are the two Venn diagrams that you have to draw for the statement all A are B. Coming on to the next statement, second statement here. No A is B. What does it mean? No element of set A is in set B. That means set A and set B are two disjoint sets, separate circles. So there is only one diagram to represent it, like this. That's it. Do you agree? Do you agree? Tell me yes or no. Do you agree now? All A are inside B. That is what it means, Dinesh. 98%. Lovely. So no hassles here. And another thing that you learn here is if you say no A is B, obviously then you can also declare no B is A. If no part of A is in B, it means no part of B is in A. Correct? Let's talk about the third quantifier here. Sum A or B. Now this is where our discussion begins, actually. Sum A or B. What is the meaning of sum? What is the meaning of sum? Few. Little. Part of it. Common. Not all. I was looking for that. Not all. No, you can't make use of Karthik. You can't make use of word some to describe some. Some means some part of it. Okay. कुछ होता है अच्छा. No. From where did you get this? Not all. See, I don't know whether I have told you this or not, but I'm observing that there is a kind of an Einstein which is, actually you're obsessed with. Bhoot. Ghost. Today, tonight, you kill that Einstein. Murder. That Einstein is actually, making you come up with your own logic. And that is called logic of convenience, whatever is convenient to you. Right? So logic is already a set of rules. Okay. Give me one book in the world which says some means not all. Please give me one book which says this. I'll tear it off anyhow. All right. So as simple as that. Please know this, my child. It's important for you that whenever you say some, you actually are talking in terms of, let us say, tippy tippy tap. Which color do you want? I want blue. Okay. No. I want green. Okay. So please know this, that when we are talking about sum in sets, all right, sum and no are going to be opposite each other. What does no say? No A is B. It means there is no intersection between set A and set B. What does sum A or B signify? It says intersection is there. It exists. So sum and no are contradictories. They contradict each other. They are opposites. No says no, there is no intersection. Sum says intersection is there. How much is that intersection? How many elements do you require for the intersection to come into existence between A and B? Please tell me. Good evening, Mansi. Hariyappa. Again, you're saying some. Obviously, more than zero. Okay, so here we go. Our first learning here. Sum means at least one. One or more. No, Srishti, you are not attending the discussion. You just became party to it. Just now I told you, if there is one single book in this world which says some means not all, give it to me, I'll tear it off. Some means intersection exists. That means that there must be at least one element of set A which is inside set B. It is an intersection. To form an intersection, the intersection to come into existence must have at least one element. And no and some are opposite each other. No says no intersection. Some says intersection exists. And for the intersection to exist, there must be at least one element which must be common to both the sets, at least one. So now onwards, for the sake of logic, for the sake of earning those 2.5 marks, you will remember that sum means at least one. Then what is the range for at least one? Could you please tell me? What is the range for at least one? It means 1% to 100%. That is 1 to all. That's it. Got it? Not infinity, Vijay, but yes, 1 to all, the maximum, which is there. Okay. All right. So let us say I wrote an examination. Okay. The marks of the examination, the total marks were 100. Okay. And when you ask me, sir, how did you fare in the examination? I say, I'll get at least 1 mark. What if the result, when the result comes out, what could be my score? I may get 1 out of 100, 10 out of 100, 50 out of 100, 90 out of 100, 99 out of 100, 100 out of 100. All right. So here, when you say at least one, it means from 1 to all, 100%, 1% to 100%. All right. So we will actually draw all the diagrams where there is an intersection between A and B. Is this okay? Do you agree? Yes? Do you agree? Please hurry up. Please hurry up. Hurry up, faster. 97%. All right, let's discuss this one then. Sum A R B. Do you agree? Can't say, Garvit, just hold on. Just hold it. Yes, sum is greater than equal to 1. Correct, Vivek. See, 83% say yes. Others, 17%, they disagree. All right, for your disagreement, let us say A is India and B is UP. Some part of India is in UP, although the complete UP is inside India. Yeah, but some part of India is in UP. The other parts of India are in Punjab, Maharashtra, Manipur, Meghalaya, Karnataka, Tamil Nadu, Andhra Pradesh, and so on. Yes, do you agree now? Okay. So, how about this? Can this be one of the cases for some ARB? In this diagram, can I say some ARB? Why not? Tell me why not. 70% say yes. Arre Baba, what is the meaning of some? At least one. What is the meaning of at least one? One to all. When you say some ARB, 1% of A could be B, 100% of A could be B. So in fact, this is another diagram. So when you draw Venn diagrams, for some ARB, you are supposed to draw only two Venn diagrams. Okay, as I told you, least intersection. Let us say 1% A is B. Maximum intersection, that is 100% A is B. Least intersection, maximum intersection. Only these two diagrams are to be used. The other two are not required. They're intermediary diagrams. Okay, intermediate. All right. So these are the two. Yes, sir. No, sum does not mean only sum. That's different. You don't need to get into that. That is such kind of statements, they appear in banking examinations, not in CSAT. I think we have seen these two diagrams elsewhere. Where are they? These are diagrams for all. Okay. So from this, we learn that whenever we have statements starting with the quantifier all, we can always derive or conclude a statement in terms of sum. All right. From all, we get sum. From all, we get sum. Okay. So all A are B. If this is one statement, from this directly you can deduce, you can derive that sum A are definitely B. If all A are B, if 100% A are B, then definitely 1%, at least 1% A is going to be B, for sure. All right, but not the other way around. From sum, you can't get all. From all, you can get some. But from sum, you can't get all. I'll give you an example. Listen to me very carefully. This is a very important example. All the students of this class are intelligent. Hold it. Just an example. All right. Don't take it to heart. All right. All the students of this class are intelligent. That means there is at least one student who's going to be intelligent. Yes or no? So from all you can get some. But if I declare some students of this class are naughty, that means I know that for sure there is one student I'm sure about that he is naughty. Others I'm not sure. Others may or may not be naughty, but one for sure is naughty. So I can say at least one student of this class is naughty, but I'm sure about one student. Others I'm not sure about. Okay. So that is why some and some not, these are particular quantifiers because they give you information only about a part of a set. All right. It does not give you information about all the members. Whereas all and no, they belong to the category universal because they're universally true for each and every single member of the set. When you say all A are B, that means you pick up any element from set A, it is going to be in B. So it is universally true. When you say no A is B, you pick up any element from set A, it will not be in B. It is a universal truth. It becomes a universal truth, means it is applicable or applied to each and every member of the set. Whereas some and some not, because some not also has some, it gives you information only about a part. It does not give you information about the whole, the complete. Okay. So it knows that there is at least one A which is B. Others I don't know. No information. Other A's may be B, may not be B. Can't say. But one I'm sure. All right. There are just chances, Garvit. It becomes a possibility, but definitely not a conclusion. So Garvit is asking that if you say some students are intelligent, are there chances that all students are intelligent? There are chances. Chances means possibility. Yes, but that is not a conclusion. It may or may not happen. But when I say all students are intelligent, for sure, some students are intelligent. At least one is definitely intelligent. Okay, from all, we get some. All right, move ahead. Some A are not B. Let's have a look at this. What does it mean? Some part of circle A is not in B. Some elements of A are not in B. At least one element of A is not in B. At least one part of circle A is not in B. It is outside B. So can I represent it with this diagram? This is A, this is B. Some A are not B. No, Chituri, you are coming up with your own logic again. 1% to 99%. Why 99%? When I've declared here, some means 1% to 100%. 97%. Sakshi, what is that not 100%? Some not is equal to kabhi alvida na khair. Kuch bhi. All right. So do you agree here also? Some A or not B. Again, using the same example. Some part of India is not in UP. It is in other states. So even this must be correct. And the third one. Some A are not B. At least one part of A is not B. Here it is 100%. So whenever you're drawing Venn diagrams for some not, you can draw these two diagrams, the two extremes. Here 1% A is not B. Here 100% A is not B. All right. So when you say sum, there is a range. So what is that range? 1% to 100%. So two diagrams have to be drawn for maximum intersection and for the least intersection. Clear? Now once again, you recognize this diagram. You've seen it somewhere. This diagram is for no. So what do we learn? We learn that whenever we say no or we have a statement which begins with no, we can directly deduce or conclude some not. Example, if you have a statement, no A is B, from that you can directly conclude some A are not B. If no A is B, then there is at least one A which is not B. I can say that, but not the other way around. From some not, you can't go to all and no. From universal, you can come to particular, but not the other way around. So from these two, you learn that if you have a statement beginning with universal quantifiers, which are the universal quantifiers? All and no. Okay. From that, you can derive a particular quantifier. All right. Which are those? Some and some not. From all, we get some. From no, we get some not. So that is something you have to be absolutely clear about. Okay. Vidya, when you say here in this diagram, there is at least one A, at least one part of A is not in B. At least one part, at least one is what? 1% to 100%. So 1% to 100% is not in B. This is 1%. This is 100% A, not in B. But this diagram is also used to represent the quantifier no. So hence we say that whenever, because the diagram for no is also included in the diagrams which represent some not. So hence we can say whenever we say no, we can always say some not. So from all we get some, from no we get some not. From all we get some, from no we get some not. From all we get some, from no we get some not. From all we get some, from no we get some not. Clear? Is this clear? So can you register this properly into your minds, please? No, third and fourth are not the same. Some of the diagrams are same, especially this diagram is same. 96%. Lovely. Another point that I need to make. If I say some A or B, can I interchange the two terms and deduce or conclude that some B are A? Correct, Femina? Yes, you've done CAT coaching. Akash, some not does not mean all. But some not in the diagrams for some not, diagram for no is also included. So whenever you say no, you can say some not. Are no student of this class is stupid. It means there is at least one student in this class which is not stupid. But if I say some students of this class are not stupid, can I say for sure that 100% students are not stupid? And okay, true. No, you can definitely. Some part of Asia is in Russia. It means some part of Russia is in Asia. When we have the quantifier sum, we are talking about the intersection. My child, intersection belongs to both the sets. Intersection belongs to both the sets. Intersection is a part of set A as well as set B. Forgot? G. G is part of A and B both, X and Y both. Right? So intersection belongs to both. So if some A are B, then definitely some B are A. Now, similarly, no A is B, you can interchange the two terms and write it as no B is A. I had explained it here. No cat is dog. It means no dog is cat. True. No star is planet. It means no planet is star. No white is black. It means no black is white. What, right? Got it? We can't, Amit. We can't. And we shouldn't. It would only be a possibility. It won't be a conclusion. From some, we can't get some not. For sure. All right. Anyhow, you get more clarity. Hold on with the doubts. So, in no, you can interchange the two terms. In some, you can interchange the two terms. And from no, what do you get? You get some not. Isn't it so? So, if no A is B, it clearly means some A are not B. If no B is A, it clearly means some B are not A. And here you find that in case of some not, the two terms are getting interchanged. But when? Well, only when some not is being derived, deduced, or concluded from no statement, only then we can interchange the two terms in the some not statement. Otherwise, we cannot. Otherwise, what happens? What is the case of otherwise? Otherwise means that if some not appears as an independent statement, it has got no connection with the statement which begins with no. Okay, it is not being derived from no. Then you cannot interchange the two terms. But when can you interchange the two terms? Obviously, in no, the two terms can be interchanged, and from this no, whatever the sum not is being reduced, it will follow the same rule. All right, same genes will follow the sum not, that is interchanging of the two terms. Are we clear? Are we clear? So, in a nutshell, it's important. I would suggest you take a pic of this. Take a picture. Your alternate career, become a photographer. No screen shooter. Why? You don't have a cell phone? Where are you viewing this? In a tablet, no? So from your cell phone, take a pic. What, Ray? And if you're watching it in the cell phone, then anyhow you can take the screenshot in the cell phone itself. No, Snehalata, some not is derived from no. All right. Sayarvind. In case of some, the two terms can be interchanged. Some A or B. Okay. So interchange. Some part of Asia, some Asia is in Russia, and some part of Russia is in Asia. Because some means at least one, and some means intersection exists, and intersection will belong to both the sets. No, this is intersection. No, it belongs to A as well as B. It is common to both. No, so some part of A is in B. It means some part of B is in A. Okay. So in case of some, the two terms can be interchanged. That was the purpose of giving you this example. Now, in case of no, also the two terms can be interchanged. No cat is dog, which means no dog is cat. They are disjoint sets. No part of A is in B. It means no part of B is in A. Okay. In case of no, also the two terms can be interchanged. Now, the sum not that you are deriving from no. From no A is B, you get some A or not B. Same sequence of A and B. No, 1, 2. So 1, 2. No B is A. You get some B or not A. 2, 1. So 2, 1. And here you see some A or not B becoming equal to some B or not A. When does that happen? It happens only when sum not is derived from no. From a no statement, if you're getting a sum not statement, in that sum not statement, you can interchange the two terms. But if sum not statement has got no connection with no statement, you cannot interchange the two terms. This is the only case. So let's go ahead. You can know this. No, 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 no. Samhita, absolutely wrong. Sum is not universal. See, again, why are you coming up with your own rules? I'll tell you, no. If it was like that, no, it is incorrect. Sum is not universal, my dear. It is particular. Universals are all and no. So please kill that Einstein tonight. Tonight happens to be the murder day. Okay. Yeah, all and no is fine, but in all you cannot interchange the two terms. No, you can interchange the two terms only in case of sum and no. And sum not is conditional. Sum not, if at all it is derived from no, then you can interchange the two terms. All right, guys. Here we go. A quick recap. Well, sum means at least one. Read it aloud wherever you are sitting. Read it aloud. Sum means at least one. At least one means 1% to 100%. That means from one to all. From all, we can get some. From no, we can get some not. In some, terms can be interchanged. In no, terms can be interchanged. If some not is obtained from no, only then, only means no other case, only then the two terms can be interchanged in some not, otherwise they cannot be interchanged. Okay, I'll give you examples for each of these. We have just started. Okay, so don't worry, it's a long class. Prashant, Prashant, I'll do the cleaning. Okay, don't worry. I'll you we will get to know the last point again and again. Amit, don't worry. Vivek, for the sake of mankind. Okay. Vivek is saying, sir, festival is going on. We can't have non-veg. Then how can anyone murder as said by you? Do it for mankind, my child. The world needs you. Okay. Let's move. Positive and positive is positive. No mathematics. Don't say sir positive into positive. Nothing. Did I put a multiplication sign here? Nothing. See, there are two kind of statements. One is affirmative. Okay. That is a positive statement. And the other is a negative statement. Okay. Affirmo is a Greek root which means I agree. I agree. Yes, yes, yes. Nego is again a Greek root which means I deny. No, no, no. I disagree. Like that. Okay. So any statement which has no, not, neither nor, never, such kind of negative words would be termed as a negative statement. I will go is a positive or an affirmative statement. I will not go, not is a negative statement. That's it. All right. So forget about affirmative. Remember positive and negative. Okay. So if two statements are positive, the conclusion obtained, maybe you are not getting a conclusion, but the conclusion obtained must be positive. Okay. Now take the case of, let us say, a motorbike. Okay. Has two tires. If both the tires are properly positively inflated, all right, the result of your ride, if at all you are riding, is going to be positive. You'll enjoy the ride. Okay. If one statement is positive, the other is negative, then the conclusion obtained, maybe you are not getting a conclusion, maybe you don't get a conclusion, but if you are getting a conclusion, then that conclusion has to be negative. A wonderful example would be life itself, my dear. Huh? Okay. So if there are two, let us say, two persons A and B, and both feel positive for each other, the the result or the conclusion of their relationship, if they have one, would always be positive. But if one person is positive about the other one, but the other is not positive, he or she is negative about the other person, the result of that relationship is going to be negative. This is also called one-sided. Okay. So, guys, please learn. Better find a person who's positive about you. Okay. So, no one-way traffic here. So, two statements given. One is positive, the other is negative. The result or the conclusion so obtained must be negative. It cannot be positive. Again, if there is a motorcycle, it's a bike. Let's say there is a bike with two tires. If one of the tire has got less air in it, it is less inflated or it is punctured, you might be still able to ride the bike, but the effect or the result or the experience would be negative. If both the statements are negative, no conclusion, sir. If there are two guys, both are negative about each other, obviously they can't have a relationship. So there cannot be any result of the relationship. First, you should have a relationship to have a positive or negative result. Okay. So simply the bike with two tires, the two wheels, if both are punctured, you cannot. And I ask you, how was your experience of riding the bike? You would say, riding? I could not even move it. Both the tires were punctured. So obviously, the experience can be felt only when you ride it. And that would be if at all you have at least one statement which is positive. If both are negative, no conclusion, sir. Okay. So I hope this is very clear. Okay. Now, what do I mean by this? All, no, some not. All A or B is in agreement. So it's a positive quantifier. No A is B. It's a negative quantifier. Some A are B. Yes, yes. So positive quantifier. Some A are not B. So negative quantifier. And that is why from positive all we were getting positive some and negative no we were getting negative some not. Remember? Okay. So these are the ones that I'm talking about. So simply here, I will be obviously doing this more in detail. Now, what is a middle term? If I give you two statements, all A are B, all B are C, how many terms do you see here? How many terms are there? How many terms are there with this? How many terms? Absolutely yes, sir. There are three terms. Which are those three terms? A, B, and C. Okay. Do you see a term which is common to both the statements? Common term. Yes, sir. B is present in both the statement. Okay. So B here is nothing but it is the middle term, common term. Now, what is the job of a middle term? Well, to connect or to establish a link or relationship between the other two terms, A and C. So B here acts as a middleman in a transaction, maybe a trader. Okay. And you had so many middlemen, even in your college also. True. All right. So common term is present in both, simply. Now, there are two types of conclusions that we will find, and both are conclusions. Both of these two types are conclusions. First is immediate conclusion, henceforth will be termed as IC. The other is main conclusion, henceforth will be called MC. ICMC, 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 ICMC. All right. What is an immediate conclusion? Immediate conclusion is the one which is obtained from only one statement. Only one statement. Okay. Like I have two statements here. All A are B, all B are C. Let me find out the ICs first. Immediate conclusion. To find out the immediate conclusion, you don't need two statements, you need only one statement. From one statement, all A or B directly. From all, what do we get? What do we get from all? Which quantifier do we get from all? Type. Which quantifier? Which quantifier do you get from all? Sum, yes. So if all A are B, then sum A are B. And in case of sum, the two terms can be interchanged also. So sum B are A. Now these are two immediate conclusions obtained from the first statement alone. From the second statement alone, in that case, what will be the ICs? Tell me. Sum B are C, sum C are B. From all, we get sum. From all, we get sum. Remember? Not vice versa, Karthik. I told you it's not vice versa. From sum, you don't get all. From all, you get sum. From no, you get some not, but not the other way around. From sum, you cannot get all as a conclusion. No. But to find the MCs, you require both the statements, right? Both the statements are required. And in that, what happens? The middle term is knocked off, eliminated. Okay. So the MC will exist between A and C. B will get eliminated. All right. Middle term B gets eliminated. That's it. Obviously. Okay. So that's that. Then let us find out the main conclusion. We have learned only one method till now, and that is Venn diagrams. Okay. Only one method till now we have learned. That is Venn diagrams. So with the help of Venn diagrams, let us find out the conclusions to these two statements. How to draw Venn diagrams, how to merge them together. Kindly have a look here, please. All A are B. Two cases I told you. You have to draw two diagrams in rough. All B are C. B is inside C. B is equal to C. That's it. There are some more diagrams which could be possible. There will be intermediary diagrams. These are two extremes. You have to consider two extremes. Least intersection, maximum intersection. Okay. Now you have four quantifiers with you. Which are those? All, no, some not. Now you know that these two are what? Positive statements. All A are B, all B are C. Yes. So the main conclusion obtained from two positive statements cannot be negative. It has to be positive. Okay. So this is positive. This is negative. This is positive. This is negative. So it clearly means that our conclusion cannot be in terms of no. Our conclusion cannot be in terms of some not. Okay. So let's find out. And as it is, our conclusion has to be between A and C. B will be removed. So can I get a conclusion like all A are C? Look at the Venn diagram. Is A inside the circle of C? Any part of A is outside C? No. Is A inside C? Yes. Even C is inside A. Both are overlapping. Correct, sir. So we can say that. So we get a conclusion here. And what is that? The conclusion is all A are C. From all, what do we get? Sum. So sum A are C, sum C are A. The interchange shall happen. So these are the three MCs. Well, why can't I have all C are A? All C are A is true here. All C are A. Right? True. All C are A is false. These C's are not inside A. So something which is true in one statement and false in another. All right. some statement which is true in one of the diagrams and false in another is a possibility. It cannot be a conclusion. What is a conclusion? It must be true in both the diagrams that you have drawn. Okay. So a statement which is true in one diagram but false in another diagram is a possibility. Not a conclusion. Clear? So as it is, these two are positive, so hence our conclusions also have to be positive. Are we clear? We have just started. I'm going to give you obscene number of examples. So I will register these concepts in your mind. Abhishek, all A or B. From that directly you can get some A or B, some B or A. You don't require the second statement. All right. So whenever you have only one statement, all right, a conclusion is drawn from only one statement. That conclusion is called immediate conclusion. And what is that? I mean, from all you will get some, from no you will get some not. In case of some, the two terms will interchange. In case of no, the two terms will interchange. Over. That you've already learned. So this is how we find out immediate conclusion. But for main conclusion, you will have to draw the Venn diagram. That is the first method that I have taught you and the only method I have taught you till now. All right. Now we graduate on to Nahi Amit, kya kar rahe ho? What are you doing? If both the statements are positive, the conclusion has to be positive. All and all. You should get all, from which you get some. This is positive, this is positive, this is positive, sir. From two positives, you can't get a negative. I explained it to you with examples. What is it that you're doing? All CRA is true and false in different diagrams. So it is a possibility that I get. But what about last statement? What last statement? Some ARC? Obviously, if all ARC, then some A are going to be C, no? Don't you see some part of A and C? Intersection between A and C. Some means intersection. Is there an intersection between A and C? Yes. Is there an intersection between A and C? Yes. That's what we talked about. And as it is, we know, whenever we say all, we can always say some. From all, we get some. Okay, it's written here. So why are we, having a dialogue about it again and again? No, there is nothing confusing, Praveen. Give yourself some time and get that word erased from your mind. Confusing. Okay, you have to do it. So it is your job to do it, not mine. Let me tell you. Okay, I'm still doing my best to throw it across to you. If you're not able to catch it, your problem. So please focus. You have to get it, son, because you have to get selected. So 100%, please be focused. Okay? Yeah, Puneet, that's what I mean. What about last statement? It is a possibility. It is not a conclusion. It is a possibility. That's what I'm saying. Okay, move ahead. Now let's talk about the second part, and that is the 7 rules of syllogism. Now, till the 7 rules of syllogism are over, we have discussed them. When we are done with them, only then you can stop, solving questions with the help of Venn diagrams and start solving with the help of syllogism. Which means that every single example which I am discussing with you here, try to solve it with the help of Venn diagram, because that is the only method you know, and that is the only method that I have taught you. I haven't taught you any other method. Okay, 7 rules of syllogism. I'm taking one example here. All A are B, all C are D. Okay, guys. IC is not a problem, I believe. From all A are B. From all, what do we get? Vivek, it was written very clearly. Okay. Yes, we get some. So tell me the ICs, guys. Please hurry up, hurry up. Come to the point. Don't just rotate and revolve, you know, on one single point. You should know what I have to catch. If you're not able to understand something, at least remember what I must remember. That's it. Okay. So some A are B, some B are A. From all CRD, what do you get? Come on, come on, come on. No, you don't need to use the word part of. Maninder, say some B are A. That's it. Okay. Yes. You got this. Some C are D interchange. Some D are Cs. These are ICs. Over. No problem. As far as finding out the ICs are concerned, if any of these four conclusions is mentioned in the question, please mark it as your answer because it's a conclusion. Now let us find out the main conclusion. Tell me, what is the main conclusion? All A are B, all C are D. We have to combine the two statements. Absolutely yes, Garvit. Very good. No, how can you say Samhita all A are D? Well, do you see any common term to combine these two? All dogs are animals, all earths are planets. Combine these two statements. So all dogs are planets. There is no common term here. Huh? So there is no conclusion. There is no middle term. And also, how many terms are these? How many terms are these? There are four terms: A, B, C, and D. Yes, sir. Now, the first rule of syllogism. The first rule of syllogism states that there must be three and only three distinct terms in the two premises or statements. All right. There must be three and only three distinct terms in the two statements. And here we have four. Okay. And how do you memorize first rule of syllogism? Can you do this much? And obviously, when we're deriving 7 rules of syllogism, these are for main conclusion. Okay. So you require at least two statements. And in the two statements, there must be exactly three terms. So what is rule 1? Three terms. Obviously, it is understood. Three terms in two statements. Three terms in two statements. It is understood. Okay, because syllogism is for two statements. One common must be there. Yes, Prashant. And also there must be three terms. Okay. All right. Now let us derive or let us observe the second rule. For that, I have taken an example. Some A are B, some B are C. Okay, guys. I see. Should not be a problem. Some A are B. Hurry up. Hurry up. What is IC? What is IC? Yo. Come on, hurry up. No, Anushka, how are you getting all? Where are you? Some B are A and from some B are C. What is the IC? What is the IC from the second statement? Come on. Some C are B. That's that. Okay, now I want you to give me the main conclusion. Please tell me the main conclusion. B is the middle term present. To combine the two statements, you are supposed to find out main conclusion between A and C. What is the conclusion? Please tell me. All right, Janta says some A are C some C are A. So how many of you say, let me give you a poll. Again, A means yes, B means no. How many of you say this is correct? Come on, let me take a poll, no? How many of you say some A are C, some C are A is correct? Tell me. How many of you say some A are C, some C are A is the conclusion? %81. Guys, you must get rid of that Einstein. I'm telling you, you're going in the wrong direction. Many of your decisions of your life are incorrect. Now, syllogism is one of the favorite branches of psychometry. Also, psychometry, to measure someone's mind. What, Ray? Didn't I tell you that you should be drawing Venn diagrams? What did you do? Huh? You sang a song, is it? All A are B, all B are C, B B cut, all A are C. Similarly, some A are B, some B are C, B B cut, some A are C. When did I teach you this? I gave you a method. Huh? You're deviating from that. You're coming up with your own method. This is where you have to check yourself. I'm not criticizing you. I'm just putting this point in front of you. I'm showing you a mirror. This is where you have to protect yourself. You're going down, in the wrong direction. Throughout your life, listen, my child, listen. Throughout your life, remember, God has placed your brain at a higher level than your heart. Yes, brain is at higher level as compared to heart. So syllogism, we are studying in the matters of brain, don't involve heart. So don't give me a feeling based response. There must be some ARC. Okay, tell me here. What did you do, beta? See, some A are B, some B are C. Any connection between A and C? You're saying some A are C. There's not even an iota of intersection between A and C. How can you say that? Because you did not draw a Venn diagram. Least intersection between A and C is 0%. Maximum intersection between A and C is 100%. That is the method I told you. How come you are coming up with your own method? Huh? Become a learner. So first learn how to learn, beta. This is important. So that is why syllogism is very important, because it basically gives you it provides you with the correct direction of thinking. Okay, follow sets of rules, follow the methodology which has been given to you, rather than coming up with your feeling based response, because this is what you have scored. Minus 3.33, sir. No conclusion. Correct, Anushka? Absolutely yes, Abhijit. Yes. Now listen to me carefully. Because I am going to make it easy for you. You see some in the first statement. You see some in the second statement. So the second rule of syllogism says two particulars. If both the statements are particular, then no conclusion can be derived. Two particulars, no conclusion. And how do you remember this? How do you memorize this? Two sums, no conclusion, over. Which means if there are two statements, some and some, or let us say some and some not, or let us say some not and some not, each case, no conclusion, no requirement for Venn diagrams. So tell me, some A are B, some B are not C. What is your main conclusion? Tell me very fast. Srishti, why are you hell-bent on coming up with a conclusion? There you go. Yes, sir. So, no conclusion. Why? Because you see two sums. See, that's a point. Srishti, why are you trying to come up with a conclusion? Huh? Why are you hell-bent? Why is this diagram? Do you agree with this diagram or not, Srishti? Srishti, I'm talking to you. Reply. Do you agree with this diagram or not? Femina agrees. Yes. Srishti, I'm talking to you, and I'm waiting for your chat. A reply. Or you want me to ignore all your messages? Then that's it. Here, if A and C have no intersection, this one diagram alone is sufficient to prove that this cannot be the conclusion. So why do you want something like this? This is C, this is A, this is B. Why? And that is why, because if you get this diagram, then this is what you're scoring. So find out that diagram in which your conclusion is defied or can be invalidated, opposite to this. And then you will be able to come out with a check, whether your answer is correct or not. So the whole point here is least intersection, maximum intersection. Least intersection between A and C. Here A and C, they still have intersection. Here it is least, 0%. Here it is maximum, 100%. Period. This is the only method of drawing Venn diagrams. Why are you adopting some other method? All right? Okay. Here we go, guys. Very fast. Tell me the IC. No A is B. Come on. Come on. Yes. Hurry up, hurry up. No B is A. From no, what do we get? Which quantifier? From no, we get sum not. So sum A are not B. Sum B are not A. Now similarly, no B is C. Means no C is B. Swap. From no, we get sum not. Sum B are not C. Sum C are not B. So you have 6 ICs here. If any one of these appear under the conclusions in the question, please mark it as your answer. Now let's find out the main conclusion. Yes, Varsha. Yes, Abhijit. Oh, Abhijit. Acha, there are two Abhijit. One is ABI and the other is ABHI. ABHI, please check yourself. Sir, what are you doing? Have you drawn Venn diagrams? Varinder, did you draw Venn diagram? See, that is a problem. No intersection means what, Sakshi? It means no A is C, right? B is out. A and C. Correct, Shad? No, you will be asked conclusion. It could be main conclusion, it could be immediate conclusion, any one of those. Don't worry, I will discuss exam questions, then you will know. First, learn the basics. Hold on. No A is C. So Priya says no A is C, which means no C is A. Achha, from no, what do we get? Some A are not C. So some C are not A. Okay, let me draw Venn diagrams. No A is B, no B is C. So, oh, correct, no? No A is C is correct, no? Ha. So you drew only one diagram. Again, you're not following instructions. So you will fail. And I'm being point blank with you because that is how you will understand. No if, no but. All right? Only straight thinking. That's how it goes. Whatever you're told, stick to it. You are no Einstein. You know nothing. You are being taught. So stick to it. Did I pinch you enough? Did I needle you enough? You want more? Huh? Why didn't you draw this diagram? No A is B. No B is C. Can you say no A is C? Between A and C, what is the intersection? 0%. Between A and C, how much is the intersection? 100%. What did I tell you? Least intersection, maximum intersection. This is the only way. You're coming up with your own way. You want to defy the rule of gravitation, jump from 12th floor and say, I will fly. Is that what you want to do? Feeling based response? You want to your own way? Take the highway then? See, listen, my boy, listen, my girl. I told you, whenever you draw a Venn diagram, beta, you draw two Venn diagrams. Least intersection, maximum intersection. Now, no deviation from this. Huh? Or you'll get it in your life. Trust me. The sooner you learn, the better it is for you. Okay? Simple. Two negatives, no conclusion. I have discussed this with you previously. Negative and negative means no conclusion. We have discussed this and you forgot. See, this is negative. See, this is negative. Two negatives, no conclusion. Puneet, look here. No A is B means A and B are separated. No intersection. No B is C means B and C are separated. No intersection. Does that mean that there would not be any intersection between A and C? All right. Let me give you an example. No dog is cat. No dog is cat. No cat is bulldog. Correct? No? No dog is cat. No cat is bulldog. Can you say no dog is bulldog? Can you say no bulldog is dog? Clear? Now you're clear? Now you're clear? Gotcha. Very good. So two negatives, no conclusion. So three rules we have learned till now. Which is the first rule? Type. Three terms. Second rule, two sum, sum. No conclusion. Which is the third rule? Two negatives, no conclusion. Okay. So here, this is what is meant. No and no. No and some not. If you get such combinations, some not and some not, each case, no conclusion. When I say no conclusion, obviously I'm talking about main conclusion. I see you will get from one statement alone. No, for that you don't need to look at both the statements. Take each statement alone, and from each of them, you pull out the IC. Okay. So, no MC. We're done with three rules. Yes, Garvit. No and some not are negative. No, not. You were not there when I was explaining positive and negative. Huh? In detail, I explained. Nidhi doesn't know three terms. Find out for yourself. All right? Okay. Seven rules of. I mean, you people dare to ask? Come on here. If you have missed something, that's your fault. All right? And if I keep on repeating, then I mean, if I miss something, I can always ask, sir. You're taking me for granted. Not done. You have missed it. Your fault, officer. Pay for it. Bad here. Come on. Look here, Nidhi. This is what we discussed. Where were you at that time? It means there must be three terms in two statements. Here it is written like this also. At that time, you did not ask me, huh? Okay. Do this. Let's find out the ICs. All A or B. Very fast, could you type, please? I give you 10 seconds. Each one of you who's planning to become an IAS officer or a UPSC servant. Absolutely, sir. Some A are B, some B are A, interchanged, and here only one. Some C are A. So ICs are the easiest to find. So are MCs actually. Middle term is A, out. So you have to find out a relation, or let us say a conclusion between B and C. What will that be? So please draw Venn diagrams. All A are B. Two Venn diagrams, sir. Some part of A is in C. Some A are C. See here. Some A are C. Least intersection, 1% between A and C. Okay. And this is maximum intersection. Clear? So between B and C, you find that definitely, yes, there is an intersection between B and C. So yes, you can come up with the conclusion some B are C, some C are B. Now let me make it simple for you. What is this? Sum. So one of the statements is sum. Then the conclusion obtained must be in terms of sum. Okay. So if one statement has the quantifier sum, then conclusion also has sum. Simple, no? One sum, conclusion sum. Least number of words I'm using so that you can memorize these rules very easily. Okay, it means what? If you have two statements, one starts with all, the other starts with sum. So all and sum shall give us our conclusion in terms of sum. All and sum not shall give us our conclusion in terms of sum not. Sum and no shall give us our conclusion in terms of sum not. You have sum, and sum everywhere. Absolutely. So this one actually I have discussed with you, but then fine. I'll still discuss this with you once again. All A or B? Tell me. ICs, please. Let's see, Garvit. Yes, you got this. Some A are B, some B are A. No B is C. Three ICs. One is interchange, no C is B, and then two in terms of sum not, which is derived from no. So some B are not C, some C are not B. All right, these are ICs. Let's talk about MCs. So B is the middle term, gone. You need the MC between A and C. Let's draw Venn diagrams. All A's are B. All A's are B. Okay, no B is C. So B and C are disjoint sets. then obviously there is no connection between A and C. So you can definitely say no A is C. Swap. No C is A. From no, what do we get? Some not. So some A are not C. Some C are not A. Correct? Now, what do you see? This is all. So this is positive. What is this? This is no. So this is negative. Alright, I've already discussed with you though. One statement is positive, the other is negative, then conclusion obtained must be negative. Okay, it is negative. See, it is negative. So simply one negative, conclusion negative. One statement is negative, conclusion must be negative. So from this, what do we learn? We get certain combinations. All and no gives us no, from which we can obtain some not. Okay. All and some not gives us some not, result or conclusion in terms of some not. Some and no gives us conclusion in terms of some not. Some of these you will find that they are getting repeated, like some and no is some not. You saw that previously also. So two reasons, no? One statement some, conclusion some. One statement negative, conclusion negative. So some and negative, some negative. It will be written, Prashant, don't worry. But as of now, we have discussed 5 out of 7 rules. Okay, tell me the rules, please. Could you please tell me the rules? What is the first rule? Please type. 3 terms. What is the second rule? Second rule. Second rule. Second rule. To sum. If both the statements are sum, no conclusion. NC. No conclusion. Third rule. Third rule. Two negatives. No conclusion. Fourth rule. One statement sum. Conclusion will be sum. Fifth rule. One statement negative. Conclusion will be negative. So by now we have discussed 5 rules out of 7 for syllogism. Are we clear with this? Let me see. You should know what all you have to register into your mind. Are we clear? A means yes, B means no. Yes, are we clear? Till now, whatever we have learned. And these are the points that you must remember. That's it. 94%. Lovely. Okay. Here we go. The tick cross table. It is also known as the distribution table, but let's not get into it. Otherwise, you will ask, so what is distribution? What is not distribution? Forget it. Forget it. Here, I'm going to assign the tick mark and the cross mark in a particular sequence to each of these quantifiers. And you have to memorize that sequence without any question asked. See, I'm not the one who has devised all these things. You might have heard of certain Greek philosophers like Galileo. Have heard of Galileo, Plato, Socrates? Yes. Yes, these are the fellas who have designed syllogism. Okay. Syllog is again a Greek word which means it is, let's say, group of rules or house of rules, like that. Aristotle, yes, I forgot. Aristotle, very much. I'm giving you rule 6 and 7. I'm yet to give you, Abhijit. Hold on. Okay. All right, sir. Let's begin. So you can see these quantifiers all know some and some not. You have ST, PT, ST is not scheduled type. So this means the first term, and this means the second term. So this is subject term, predicate term. Remember, A is first term, B is second term. Everywhere. I've taken examples also here. So these are the examples in front of you. And these are the quantifiers. So this is how tick and cross mark are to be assigned, or they are to be memorized for each of these quantifiers. All is tick cross, no is tick tick, some is cross cross, some not is cross tick. I'll help you. Okay, let's have more handshakes with this table. Let's have more handshakes with this table. Okay, see, all and no, you know that these are universals. So universals actually give you information about each and every element, universally true. Okay, so that is why they begin with a tick mark. And some not, you know, are particulates. So they give you information only about a part. They do not give you complete information. They do not give you complete information. So they start with cross. Also, no, you have tick tick. All right, let me assign these symbols here. All A are B, tick cross, no A is B, tick tick. Some A are B, cross cross, some A are not B, cross tick. Okay. Now, no A is B. I tell Mr. A and Mr. B, you both take your, whatever the symbol that you have over your head, tick mark or cross mark, and exchange your seats along with the symbol. So, what does it become? It becomes no B is A. B carries his signal, his symbol, tick mark to A's place. A carries his tick mark to B's place, and they sit in each other's place, exchange their places. We get a no B is A. Still, the order of tick marks, does it change? Does it change the order, the sequence of tick marks? No A is B is tick tick. No B is A is tick tick. Hence proved, in case of no, the two terms can be interchanged. In case of no, the two terms can be interchanged. Now, what do I have here? Some A or B. If I ask them to interchange their places and carry the symbols along with them, it shall become some B or A. B carries its cross mark, A carries its cross mark. Does the sequence of cross marks change? Cross cross. Some A or B cross cross, some B are A cross cross. Hence, the proof that in case of some, the two terms can be interchanged. Is that clear? So the two terms can be interchanged only for two quantifiers. Which ones? Some and for no. So what are these? These are opposites or contradictories. They also form complementary pairs. I'll come to that later on. How? No is tick tick. Some is cross cross. Tick and cross are opposite each other. Don't call them as right wrong. Why can't you call them as tick and cross? That's my point. You want to again devise your own methodology, coin your own terminology. Why can't you take things the way they are presented to you? Why is it that you need to convert it into some other form to understand? Why have you convinced yourself that this is how your brain functions? Well, your brain can very well adapt, take, imprint, register whatever it is told as it is with no changes. Okay? No, Praveen, don't make that declaration to yourself. Okay, beta, you are much better than you think. You have more potential than you think. You don't realize. You have the most powerful thing and weapon in this world. Anyhow, with me in your notebook, please pick up your pens. Pick up your pen. Pick up your pen, please, officer. IAS officer, IPS officer, huh? Pick up your pen. Come on, hurry up. And with me, please start writing this table like this. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All tick cross, no, tick tick, some, cross cross, some not, cross tick. All no, some not, all no, some not, all no, some not, all no, some not, all tick cross, no, tick tick, some, cross cross, some not, cross tick. 13 times I've written. Yes, IFS, IRS, whatever I and S you want to become. Fill in the blank. Not 11, Ray. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, Ray. And Ray. Huh. So now I assume that you memorize this, because if you memorize this table, then only we can discuss the other two rules. Okay. And now in a jiffy with the other two rules, you'll be able to solve questions. Just watch how the questions get solved, how you find MC within 5 to 10 seconds. Watch it, man, now. Here we are. All ARB, all CRB. Okay. Tick. Okay. Just solve this question now with the help of Venn diagram. Solve this with the help of Venn diagram, please. Okay. ICs will take all ARB is some A R B, some BRA. All CRB, some CRB, some BRC. Give me your main conclusion, please. B is the middle term. Main conclusion will exist between A and C. Wow, Garvit. Anushka, did you draw Venn diagram? Sakshi, did you draw Venn diagram? Balaraju, did you draw Venn diagram? Shijin, did you draw Venn diagram? Priyanka, did you draw Venn diagram? Without drawing Venn diagram, again you're coming up with a conclusion. What Venn diagram have you drawn? All ARB. All ARB. All CRB. All CRB. You forgot to draw this diagram. Least intersection between A and C. Maximum intersection between A and C. Huh? All C are inside B. But A and C, no intersection. Then how can you say some ARC? You can't say some ARC here, right? Okay. And here, because 100% ASC, you can't say no ASC. Over. So let's get rid of diagrams. Guys, most important thing coming your way. It's called let's start. All ARB, tick and cross. All CRB, tick and cross. What is the middle term? Middle term is B. And middle term is getting 2 cross marks in both the statements. Middle term is getting 2 cross marks in both the statements. All right. So, over. What did I do? I put the tick cross, and saw that middle term is getting 2 cross marks, hence no conclusion. So that is the sixth rule. If middle term gets 2 cross marks, no conclusion. If middle term gets 2 cross marks, no conclusion. Anyhow, middle term will appear twice, right? Once in statement 1 and once in statement 2. And in both the statements, it is getting cross mark above its head. Hence, no conclusion. 2 cross, no conclusion. Middle term, 2 cross mark, no conclusion. Repeat with me 3 times. Middle term, 2 cross marks, no conclusion. 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 Wonderful. You got this. Wait, Chituri, wait. First, you please take whatever is being given to you. Huh? It's like, something is being served to you and you are looking here and you're saying, hey, what about that? Please serve me that also. Hold on, have patience. I'll give you everything. Okay? Don't worry, sir. You'll become an expert before you actually finish off this class. Have patience. Every single type is covered. Every single doubt will be resolved. Let's do this. No, we are not talking about possibility, Abhishek. Let's stick to what we are talking about. Don't come up with new things. We can also solve with here is 2 sums. That why no main conclusion here. What are you talking, Shamali? I'm not able to get you. Where are 2 sums here? These are 2 alls. Huh? All A are B, sum B are C. All right, give me ICs, guys. All A are B. Sum A are B, sum B are A, sum B are C. Swap. Sum C are B. That's it. Main conclusion, please. So B here is middle term, no? Sum A are C. Yes, Karthik. Correct, no? C and all A are C. Correct, no? Not drawing Venn diagrams. Don't know how to draw Venn diagrams, no? All A are B. Okay. 2 standard diagrams. Sum B are C. Do you see any intersection between A and C? Because you've not drawn the 2 extremes. Here, how much is the intersection between A and C? Okay, na? Intersection is 0%. And here, intersection is 100%. 2 extremes. Least intersection, maximum intersection. Least intersection, maximum intersection. There is no other way. If you are adopting any other way, you'll get lost. That's all. It'll happen. See, if there is a path which is defined on a marooned island, you will definitely get lost if at all you take some other path. Don't become a pathfinder. Okay? So follow your guide. That is more important. No, Amit. No, Amit. I said if conclusion is possible, the conclusion obtained. But there is no conclusion obtained. If there is no conclusion, no conclusion. But if the conclusion is obtained, then the conclusion must start with sum. Okay. And I also told you, remember this, but you don't remember this, that till we have discussed all the 7 rules, all the examples must be solved using Venn diagrams. Very conveniently, you have forgotten that, sir. No, sir. You have to be honest with yourself. So this is where you have to make corrections in your approach, beta. Okay, so it's all about fixing your erroneous zones which are there in your approach, in your thinking. All right, the kind of mindset that you possess, get it right, and that is the strive before we achieve success in life. Okay, now watch here. All A are B, some B are C, middle term B, two cross marks, no conclusion, over. You don't need Venn diagrams actually. 5 seconds is all it takes. 5 seconds is all it takes. All right, sir. All A are B, some B are not C, middle term, two cross marks, no conclusion, over. I'm deliberately not looking at ICs right now because now I'm convinced that you can do ICs. How is that? Tell me. No, ICs will be there. ICs will be there. I'm not considering those ICs because I know you can handle them now. You can find out all ARB is what? Some ARB, some BRA. ICs you can derive only from one statement. There no other rule applies. From all we get some, from no we get some not. That's it. Some B are not C, no IC. I told you no. Interchange will happen in some not only when some not is derived from no. Here, some not is not derived from no. So no interchange. No IC. Got this? Ankita, then obviously there will not be any main conclusion. Middle term is a must to join the two. Okay? It is a link. If the link is not there, obviously, then you won't be able to come up with a main conclusion. Got it? No, Prem. What is the need of IC is not the question, beta. What if, see, there are three conclusions given to you. One of them will be some A or B. Okay. Another one will be, let us say, some A are not C. Another one will be, let us say, no A is C. And then there will be four choices. Huh? Choice B here will say only one follows. Choice A here says only 2 and 3 follow. Likewise, and here it says none follows. And then you have to choose no. Then some A or B is definitely a conclusion. But some A are not C. Between A and C, you can't get a conclusion. Why? Middle term is getting two cross marks, so no conclusion. So similarly, A and C, no. So only one follows. So definitely ICs are required. No, you should know how to find out ICs. Okay? Because the conclusions might consist of ICs, as you will see in the questions that follow. CSAT questions I'm talking about. So hold on for some more time. So rule 6, if middle term, two cross mark, no conclusion. Middle term, two cross marks, two cross, no conclusion. Middle term, two cross, no conclusion. Middle term, two cross, no conclusion. Simple little star. And now, the easiest of all and the most important, rule 7. Here we go. After this, I will give you a break. So give me another 3-4 minutes. 3 minutes. You remember the very first example that we have taken, all A are B, all B are C. So all A are B, all B are C. Now please have a look here. Is middle term getting two cross marks? Is middle term getting two cross marks? No, it gets a tick mark as well. In the first statement, it gets a cross mark. In the second statement, it is assigned a tick mark, right? So we may get a conclusion. See, if middle term gets two cross marks, no conclusion, over. But if middle term gets at least one tick mark, you may get conclusion. And what is that conclusion? You remember, with the help of Venn diagrams, we arrived at these conclusions. So let me just assign tick cross to these also. All ARC, tick cross. Some ARC, cross cross. Some CRA, cross cross. I'm taking a case where I've already derived the conclusions. Okay. And I'm using this complete example, two statements along with conclusions, to basically establish the seventh rule. Okay. Now we want a conclusion, main conclusion between A and C. I'm not talking about ICs. ICs you can find on your own. Okay, so I'm not writing ICs. You can write on your own. Now I want you to notice something here. What does A get here? Tick mark in the statement, first statement. And what does A get in the conclusion? Tick mark or cross mark. In one conclusion, it gets tick mark. In the other conclusions, it gets cross mark. That means there is no rule as such for any term which has a tick symbol. So a tick may get a tick or may get a cross. The term which has been ticked, that term may be ticked or may not be ticked, may be crossed in the conclusion. Right? So A here gets a tick mark. So it may get a tick mark in the conclusion. It may get a cross mark in the conclusion. No hard and fast rule. But. Observe C. You want a conclusion between A and C. Now C is getting a cross mark in a statement. And when you look at the conclusions also, C gets a cross mark in each of the conclusion. Yes, so sir, that is the rule. That is the rule. A term which is crossed in a statement must be crossed in the conclusion. All right. Hindi mein, if I write, okay, so it is cross wale ko cross milega. If you know Hindi. If you don't know Hindi, simple. A term crossed, a term which gets cross mark in a statement must get a cross mark in the conclusion also. So the rule is for the crossed term. Any term which is crossed in a statement must be crossed, must sit on that seat at that place where cross mark is there. So cross mark, person will go to cross place only. So cross wale ko cross milega. That is your rule 7. Let's play. All A or B. No A is C. Now watch this. Middle term is safe. What do you mean by safe? Well, it does not get 2 cross marks, because if middle term will get 2 cross marks, no conclusion. So it is getting at least 1 tick mark. Yes, sir. Now also, you know about these combinations. This is positive, this is negative. So your MC here has to be negative. So you know that all and no should give you a no or a some not. Correct? Now what is no? Tick tick. What is some not? Cross tick. As per the distribution table. Right? And what is the 7th rule? Cross wale ko cross milega. The cross term here is B. It has to sit at that place where cross mark is there. It cannot sit at tick mark place. So no has 2 tick marks. It has no scope for cross mark place. But some not has cross mark in it. So your answer has to be in terms of some dash, cross, are not, tick, my child. B will directly come here. C will go here. Over. As simple as that. No Venn diagrams. The cross will go to cross place. Over. Right? Look at this one. Some A or B. Cross cross. No B is C. Tick tick. What is your middle term? B. It is getting a tick mark. It does not get 2 cross marks, because if it gets 2 cross marks, no conclusion is possible. True? So now you want a conclusion between A and C. And this is what? Some and no. And some and no, you know, is some not. So your answer has to be some cross are not tick, because some not is cross tick. Okay. Who will sit at this place? Who will sit at this place? Please type. Who will come at this place? A or C? Tell me which one. Arey beta, B is the middle term. No, middle term is out. Middle term is eliminated. Obviously, A comes here. C goes here. Some here not C. Period, over. As simple as that. Cross to cross मिलेगा बिल्कुल भैया. Yes, without Venn diagrams, it becomes very easy. See, a term which is crossed in a premise or a statement, let us say, premises are statements of information, must be crossed in the conclusion. Cross वाले को cross मिलेगा. So, 7 rules of syllogism we are done with. As you wanted it on one single slide, here it is. 3 terms, 2 sum, no conclusion, 2 negatives, no conclusion, 1 statement sum, conclusion will be sum. 1 statement negative, conclusion will be negative, provided the conclusion exists. Middle term, 2 cross marks, no conclusion. Term crossed in a statement must be crossed in the conclusion. Cross wale ko cross milega. Okay. Let me revise. These are the combinations that I talked about. With every rule, baby, I have written these combinations. All and all. So read this plus as and. Ampersand. All right. It doesn't mean mathematical plus. All and all will give you all, from which you will get some. Why? Positive and positive gives you positive. From all you get some. All and all will directly give you some. I'll give you examples. 1 positive, all and negative will give you negative. Sum not is also negative. You will get from no. All and negative. Positive and negative. That is all and no will directly give you negative, sum not. We'll discuss. All and sum. 1 sum, conclusion sum. All and sum not. 1 positive, 1 negative, conclusion negative. Sum not. 1 sum, conclusion sum, 1 negative, conclusion negative. Sum and no, sum not. 1 sum, conclusion sum, 1 negative, conclusion negative. Got it? Now, all this will be there in front of you when I talk about the examples. I'm going to take 15 examples. We are yet to discuss examples, sir. I'll discuss all the combinations, that can exist amongst these 4 quantifiers. Okay? That thoroughly we'll do it. Okay? That much in detail, so that we do not commit any mistakes. And then we will take up the questions that came in CSAT examination. Now, which are the no conclusions type? 2 sums, no conclusion. 2 negatives, no conclusion. You remember this tick cross table? All tick cross, no tick tick, sum cross cross, sum not cross tick. And now this will be there at every single slide. And this is all that you now need to remember. And if you forget any of these, let me just tell you that you will be a recall value has already been established and registered into your mind. You would still be able to derive it there. All and all, can my conclusion be in terms of no? I don't remember the combination all and all. No. From 2 positives, I can't get a negative. No. So which are the other positives? All and all. All and sum. Yeah. So let us see with tick and cross, what do I get? Get it? So these combinations. Then rule number 6 and 7, middle term 2 cross, no conclusion. Crossed term will be crossed in the conclusion. Cross wale ko cross milega. And this table. That's all that you need. You don't require anything else. No Venn diagrams required. And this would be present. All right. Here, I'm just showing it to you. I'm not solving. On every single question that I'm going to discuss with you. Got this? Till 15th. All this is going to be there. Is this clear, bacha? Okay. You don't need to know the basis on which this cross mark and tick mark was given, Muskan. That's why I insisted at that particular moment itself. I had specified, don't ask me this. Just learn this table. Okay, just learn this table. Yeah, Garvit, what is your doubt? What is your doubt? Please tell me. Samin, it is mentioned what they want, whether it is IC or MC. No, it is not mentioned. You have to identify whether it is IC or MC. It will be your answer. You will see how to solve questions. I'll tell you. So hold on. That part is remaining. How to solve questions. How the questions seem like. What do they demand? What should be your approach? That is what we will take up after the break, right? Okay. Yes, Garvit, where is your doubt? If instead of all ARB, all BRA was written, the tick cross will simply reverse. No. Yes. If you have all ARB, why will you reverse it? Because if you write it as all BRA, this is still tick cross because all is tick cross. There is no reversal. Huh? Why? Where? From where is that reversal coming from? No, the statements do not have same meaning, Garvit. Where are you getting it from? All ARB does not mean all BRA. When did I tell you that? It is only in the case of some and no that interchange will happen. Reversal will take place. Not in case of all and some not, beta. From where are you getting it? Einstein, kill, 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 kill. Tonight is the night. Killer, yeah. Okay. What is there to explain in some not, Sanjay? Yes, Nehlata, just wait for the questions. When the questions come, you will know what I see, what MC, what should I take as conclusion. Right now, we have just discussed the basics. We have just discussed the requisites. These are the requisites to solve a question. Now we will solve questions, 15 examples. We will come up with conclusions, and later on, we will pick up examination questions. That is exactly when you will come to know about the approach to solve questions in the exam. Garvit, you clear here? Why cross tick? Because that is the way Aristotle, Galileo, Plato have made it. Yes, 7 rules plus tick cross table and these combinations, which you will form on your own. I mean, come on here. Some and no is some not here. Come on. All and some is some. Prem, from the first class, I have been saying R.S. Agarwal. Okay, verbal and non-verbal reasoning and quantitative ability and Baiju's book. These two are enough for practice. Then take up sectional tests. They're available over Google. Take mock tests always in written form. Don't take online tests because you're ultimately not going to attempt an online test. It's going to be an offline test. All right. So go to the center and attempt the test. Okay. And then the PYQs, previous year question papers. After that, you'll have a good grip over concept. So practice at least 100 to 150 questions on every topic which is being taught to you. That much has to be given in. All right, you are hungry. Okay, need to have dinner now. Yes, please do so. So I have 7:14 here exactly. So let's catch up at 7:29, guys. 7:29 it is then. All right, guys. Enjoy your break. Enjoy your dinner. Yes, warriors, officers, are you back? Harshita, all and all, both are positive. You get a positive, which is all, from which you get some. These rules were discussed initially. No 2 minutes, Vivek. We're starting now. You had your 15 minutes. All righty then. Here we go. Very first example as we had taken. So IC is all ARB, some ARB, some BRA, all BRC, some BRC, some CRB. This you know. So this question I've solved twice. This is the third time I'm solving this. So tick, cross. First check the middle term. Okay. Here it gets a tick bar. It should get at least one tick bar. Then only we can get a conclusion. Then all and all, this combination you have. Okay. What should we get? Both are positive. We should get positive. And what is that positive? All. All tick are cross because all is what? Tick cross. Okay. Who should come at this place? C. And remaining A will come at this place. So all A are C. From all we get some. So some A are C. Interchange. Some C are A. Over. Is that clear? Is that clear? How many of you are there? Let me see. Your attendance, please. Is this clear? Attendance, please. Officer on duty. Okay, here we go. Look at this one now. All A are B, all A are C. What do you have here? A is the middle term. It is getting 2 tick marks. It is not getting 2 cross marks. So we can get a conclusion. Now, what about the combination? All and all. All and all gives us all, from which we get some. All and all can directly give us some. How? Because B is getting a cross mark, C is getting a cross mark. In all, you have tick and cross. But B and C both must sit at that seat which is marked cross as per the 7th rule. Cross term should sit at crossed place in the conclusion. Okay. So hence we will get some B are C, some C are B, some C are B. So B and C both are getting cross marks, so they will as well sit at cross mark seats. Clear? Look at this. All A are B, all C are B. Yes. What's your conclusion? Come on, type. What's your conclusion? Absolutely, sir. No conclusion. Lovely. Middle term is getting 2 cross marks. Kamlesh, correct. All A are B, tick, cross. All C are A, tick, cross. Middle term, A is getting a tick mark here, right? All and all should give you an all here. All tick, R, cross. Okay. So it's B who will occupy this seat. Remaining seat will go to C. All C are B. From all we get some. So some C are B, some B are C. Look at this one. All A are B. Tick cross. No B is C. Tick tick. See? So all and no. What do we get? We get no, from which we get some not. Yes, because one is positive, the other statement is negative, so our conclusion has to be negative. So no tick is tick. The middle term here is B. It is getting a tick mark here, so we can get a conclusion. A and C both are getting tick marks, so no A is C, no C is A. From no we get some not. So some A are not C, some C are not A. Got it? Parveen, sir, we will not consider sum in fourth example. What do you mean by that? We will not consider means because we are getting from all, we are getting some, and one of the terms is getting a tick mark, one of the terms is getting a cross mark, and tick cross is available in all, so we can as well go with all because it has a tick and a cross. And some anyhow you're getting here, no? From all you're getting some. So even all the three are conclusions. Any of these can appear in the question, right? As a conclusion. Let's do this one. All A are B, no A is C, middle term is A. It's not getting two cross marks. Instead, it is getting two tick marks, right? Now, all and no, we get no, we also get some not. Well, no is tick tick, some not is cross tick. Yes, please observe B here. It is getting a cross mark. So we want that quantifier which has a cross mark in it. Which one? Which one should we take? No or some not? We should take a some not. So our conclusion here shall become some cross are not tick. All right, B is getting a cross mark. So it will come here, some B. C will occupy this position. Some B are not C. No interchanges, nothing else. Because from some not, we don't get any IC. Got it. Very good. You've answered this correctly. Now look at this one. All A are B. Oh ho, some B are C. What's your conclusion, dear? Please tell me very fast. No Venn diagrams. We are omitting Venn diagrams now, Chandrasekhar. We have graduated on to tick cross method. So because, see, you will take a lot of time to draw the Venn diagrams for this. B is getting two cross marks, so no conclusion. Over. Sixth rule comes into play. So this is faster. All A are B. Some A are C. Middle term. A is getting a tick mark here. All right. All and some. One sum. Then conclusion is also sum. Correct? B is also getting a cross mark. C is also getting a cross mark. In sum, you have cross marks only. All right. So some B are C. Some C are B. Interchange happens. All right. So makes it easy and faster. Yes. No chance of committing an error. All A are B. Some B are not C. Tell me, sir. And C, yes. No conclusion. Why? Middle term is getting two cross marks. Here as well as here. Easy, no? And fast. Okay, now this one. All A are B. Some C are not B. So cross tick. Middle term. B is getting a tick mark here. It's not getting two cross marks. How about the combination? All and some not. What do we get? All and some not. As it is, if one statement is sum, conclusion must be sum. One statement negative, so conclusion must be negative. So some cross are not tick. Then who's getting cross? C is getting a cross mark. Has to sit here. So A goes to the remaining place. Get it? Some C are not A. See, it will take a lot of time with some not if at all you want to draw Venn diagrams. Okay, not less than a minute. And this we have solved within 15 seconds, maybe. All A are B, some A are not C. Middle term is getting tick mark here. Okay. Then combination all and some not. What does it give you? Some not. So some cross are not tick. B is getting a cross mark. So it sits here. C gets a tick mark. Over. That's simple it is. Take this one. All A are B. Some C are not A. Careful, careful, careful. Watch it. As it is, middle term A is getting two tick marks. It is not getting two cross marks. So we may as well get a conclusion here. All and some not. The second step is check for the combination. All and some not. All and some not gives you a some not. So some cross are not tick. Now hold it. B gets a cross mark. Oh, C also gets a cross mark. How is it possible that both B and C will sit at this place, cross place, and this will go empty? Some BC are not dash. Bad, no? So although middle term is not getting two cross marks, but still we are not getting a conclusion. Why? Why? Because the last rule, the seventh rule is getting violated. Okay. So that's why no conclusion. Take this one. Some A are B, no B is C. Middle term B is getting tick mark here. Okay, all good. Now we've got to form a conclusion between A and C. See, ICs I'm leaving because I believe that you people are good at now finding out the ICs. So check the combination. What about the combination? Some and no. What do I get? Some and no. Some and no is some not. So some cross are not tick. So A gets a cross mark, will occupy this position. C gets a tick mark, occupies this position. Some A are not C. Over. How simple is that? Some A are B. No A is C. Middle term A gets a tick mark here, does not get two cross marks. So all good. We may get a conclusion. Next step, check for the combination. Some and no. What do we get? Some not. So our answer must be some cross are not tick. B gets a cross mark. B comes here. C gets a tick mark. C comes here. Over. Perfect. Now look at the 15th question, please. A is B. B is not C. Do you see any quantifier? All no, some not? No. Now, now in that case, if you have a statement, let us say, X is Y, or you have a statement X is not Y. When you see that there is no quantifier which is used, all no, some not is not present, then by default use universal quantifier. Which ones? All and no. I mean, this is what? This is positive, right? So make use of all. So X is Y is all X are Y. X is not Y is negative. So no X is Y. Okay. So this A is B becomes all A are B. B is not C becomes actually no B is C. So you rewrite this as I'm doing it here so that initial question does not get spoiled. All A are B, no B is C. Tick, cross, tick, tick. Middle term, all good. It's getting a tick mark. All and no, because A is getting a tick mark, C is getting a tick mark. In no, we have two tick marks, so we can definitely use no. Okay, so no A is C, which means no C is A. From no, what do we get? Some not. So some A are not C, some C are not A. Yes, Amit, correct. Both are negative, no conclusion. Two negatives, no conclusion. All right, sir. The moment that you all waited for. Question from previous year's papers. Now, we will see how we are supposed to approach any question. Okay. Now, please allow me to solve this question. Okay. Don't immediately start solving it. I know you're excited about testing yourself. Okay. But you don't necessarily have to do it. Okay. So here we go. You have two statements. So this is how the question looks like. CSAT 2022 question. Two statements are given followed by two conclusions. This is how the question appears. So these are the two statements. All pens are books, no chair is pen. And it is followed by four conclusions. 1, 2, 3, 4. You have to check which out of these four conclusions will follow the two statements as a conclusion. And then you have to mark any of these four choices as the answer. Let's start. All pens are books. No chair is a pen. So the middle term here is pen. It is getting tick mark here. Now, what is all and no? No, as well as some not. In case of no, we have two ticks. In case of some not, we have a cross and tick. And mind you, books here is getting a cross mark. So we need our conclusion in terms of that quantifier which has a cross mark in it. Okay, and that is some not. Correct? So our conclusion here should be some books are not chair. Cross, tick. Correct, sir? Now look at conclusion 1. And this is between books and chair. Books and chair can't have it in terms of all. It has to be in terms of some not. Out. So chairs and pens. Wait. No chair is pen. From no chair is pen, can you get some chairs or pen? From no, we get some not. We don't get some. So this is out. Okay. Book, chair. Again, book, chair should be in terms of some not. Here again, it is given in terms of all. So this is out. Chair, book. Book, chair should be in terms of some not. Here it is given in terms of no. Out. Choice D is the correct answer. Now, Sakshi, I very clearly requested you people that please allow me to solve the question. Okay, maybe you were not listening to me at that time. If you allow me to solve the question, then only you will come to know about the approach. So first question I wanted to solve. Okay. Henceforth, there are going to be questions where I will give you polls. So have patience, beta. By conclusion, 4 does not follow. Garvit, what is the conclusion between books and chair? Some books are not chair. And what is given here? No chair is book. From some not you get no. or from no you get some not? From no you get some not. So a conclusion has to be in terms of some not. Okay, it cannot be in terms of no. That is why it was wrong. So, same question. I have written the rules which will arrive here. Okay. Now, I want to solve this question. Why? Because there are three statements here. And I want to teach you how you should solve three statement questions. Two statements, previously you have directly found out the conclusion. Three statement question, please directly go to the conclusion. Start with the conclusions. You can read the statements, not an issue. It is between doctors, teachers, engineers, scientists. Okay. Go to the conclusion. Conclusion one is between scientists and doctors. Okay. Now choose those two statements only because there are more than two statements. So out of more than two statements, you will choose those two statements in which one of the statements has the term scientists, the other statement has the term doctors, and the two statements should also have a common term, right? So that we can combine them. So what do you see? Last statement has scientist. First statement has doctors. And doctors is with teachers. Scientist is with engineers. No common term. So wait for a while. Don't take up conclusion one right now. Okay. First resolve conclusion 2 and 3. In the process, you will come out with some conclusion which you can combine with one of the statements here and hence form a relation between doctors and scientists. What do I mean? This is what I mean. Sir, have patience. Leave conclusion one for a while. Why? Because scientists and doctors are present in different statements where the common term is not there. Teachers, engineers. Okay. So conclusion two, all engineers are doctors. Now have a look here. This is where we have engineers. This is where we have doctors. And to combine the two statements, we have teachers. This can be resolved. Yes. Some doctors are teachers. All teachers are engineers. So what do you see? What do you find here? The middle term teachers is getting a tick mark. So we can get a conclusion. What shall be the conclusion between all and some? What shall be the conclusion between all and some? Has to be some. Correct? One sum, conclusion sum. So some doctors are engineers. Some engineers are doctors. Okay. So conclusion two says all engineers are doctors. Incorrect. No? The answer has to be in terms of some. All and some gives you some. It does not give you all. So conclusion two for sure is out. Okay. Conclusion two for sure is out. Now conclusion three. Some engineers are doctors. That we already have. No, some engineers are doctors. Here. Conclusion three is anyhow correct. Now let us go back to conclusion one, which is between scientists and doctors. So what we shall do is we shall combine these two statements. Okay. That is this one is the conclusion obtained from the first two statements. The conclusion obtained from the first two statements can be combined with the third statement, right? In continuous fashion. So some doctors are engineers, let us say, and you have all engineers are scientists. So engineers here happens to be the middle term. Okay, so cross, cross, tick, cross. Okay, so engineers is getting a tick mark here. All good. Now next thing is all and some give you some. So definitely by combining these two statements, we get some doctors are scientists, some scientists are doctors. So one is correct, three is correct. So choice C should be your answer here. Now, there is something which I would like to point out here. Let us say you have some statement like all A are B, all B are C, all C are D, and you want to verify whether this can be a conclusion. All A are D. Can it be a conclusion? Let's find out. Now, what you basically have to do here is you combine these two statements first. Why? This is where you have A, this is where you have D. And A is with B, D is with C, no common term. Is it or not? No common term. So what we will do is we will first combine statement 1 and 2, get a relation between A and C. Then whatever A and C relation we get here, C will become common and we can have a conclusion between A and D. So what do we have here? All A are B, all B are C. We get a all A are C. Okay. Now C here can be cancelled easily. You get a relation between A and D. And what shall that be? All A are D. All right. So what you can do is, if at all you are given a conclusion in which there are two terms and the two terms are present in two different statements with no common term, then what do? You combine, you keep on combining those two statements which have a common term. Okay. And then finally you combine it with the third one. So this is what we did here. Now let's try this out. Come on, guys. I'm giving you a poll for this one. How much was it? %44, is it? It is 12 to 5. I was told 10 to 5 actually. SME sir, please correct me if I'm wrong. It is 12 to 5, is it? Sabir told me 10 to 5. All right, it is 12 to 5. So 12 to 2, you have a session, and then 2 to 5 doubt session. All right, let's see what we have to do here. Let's solve this. Okay, so tomorrow you have this class. Please make sure that you are there if you want to benefit from it. All right, sir. So conclusion one is between radios and watches. This is where we have radios. Oh, this is where we have watches. Radios is with mobiles. Watches is with computers. So again, I cannot combine these two statements because it does not have any common term. So I'll first verify conclusion two. Certainly some mobiles or watches. Can I combine these two? Well, why not? Watches, mobiles, computers is the middle term. Yes, all mobiles are computers. Some computers are watches. Cross mark, cross mark. So between mobiles and watches, I can't have a conclusion because middle term computers is getting two cross marks, right? So conclusion two does not exist. Now coming back to conclusion one, radios and watches. Well, obviously, when you can't have any relation between these two, you will not be able to have any relation between watches and radios. You can't go up. True. Even if there was a relation between all and some, this would have been in terms of sum. And sum, no conclusion. True. Conclusion one does not hold good. Choice D is the correct answer. Okay. I did. Shamil. Got it. Very good. Look at this question, sir. One more question, CSAT 2021. Here, I mean, I need to explain a concept to you. So let me just do it along with you. But most of you will get it incorrect. No use. You'll get it incorrect. Yes, I challenge you. Still, if you want, you can have a poll. Obviously, you need to practice Garvit. Around 100 questions you can practice from R.S. Agarwal. The more you practice, better grip you will have on the topic. Be fast. Yes, Abhijit, very good. You remember. Only 28% got it correct. No problem. No problem. We are just learning. No, it is just a learning stage. This is not a CSAT examination. No. Anyhow, I told you three statements, so go directly to the conclusion. Certainly, some almiras are tables. Look for the two statements, one with almira, the other with tables, and a common term. Almiras, tables, common term, chairs. All good. All good. Some almiras are chairs. All chairs are tables. Chairs, chairs. Here, chairs is getting a tick mark. So middle term is safe. I mean, we can go ahead and check for the combination to the next step. Next step is sum and all. Sum and all is sum. So definitely some almiras are tables and then vice versa. Okay. shall be correct. Okay. Now, conclusion 2 is between cats and chairs. Okay. Some cats are almiras, some almiras are chairs. You have chairs here, you have cats here. The middle term is almiras. Okay. But do you think we can get a conclusion between cats and chairs? Some, no conclusion. Two sums, no conclusion. Rule 2, syllogism. Okay. But the statement says some cats may not be. All right. So may or may not suggests that it is a possibility. Now, do you have a conclusion between cats and chairs? No. Do you know how many cats are chairs? No. We don't know anything. We don't know how many cats are chairs. Okay. Now, please know this. You don't know anything about cats and chairs. How many cats are chairs? So, any number of cats could be chairs. Any number of cats may not be chairs. Anything is possible. Anything is possible. Okay. When you don't have a conclusion, then anything is possible. When you don't have a conclusion between two terms, then anything, any kind of a relation, any kind of a quantity, or any kind of uh, a statement is possible between the two terms because we don't know anything about them. Maybe. Okay. So, as we do not have any concrete conclusion between cats and chairs, so some cats may not be chair, some cats may be chair, all cats may be chairs, or all chairs may be cats, or no chair is cat, no cat is chair. Some cats are chairs, or maybe some chairs are cats. Anything is possible. Anything is possible. So even this is fine. So both are correct. Choice C shall be the correct answer. No. Namrata, it is not a conclusion, beta. That's what I'm trying to tell you. It is may not. May. I may or may not. Not sure. Okay. If it was written some cats are not chairs, then it is a definitive statement. Then we would review the statement whether it is a conclusion or not. But the statement is some cats may not be chairs. So, yeah, it is possible. Okay. So, it is possible. They may not be chairs. Excuse me, sir. Here, possibility of statement 2 is not asked, but its conclusion is asked. Okay, Anshul. What makes you feel that this is wrong? Conclusion 2 is incorrect. Do you have any conclusion, any relation, any count of how many cats are chairs? For sure, you know all cats are chairs. For sure, you know some cats are chairs. For sure, you know no cat is chair. Do you know anything for sure? Because conclusion is for sure. Yes, Vivek, what is your doubt? No, Muskan. That's all right, Vivek. If you're comfortable with Venn diagrams, go ahead. Okay, Muskan, this is what I have for you. I knew it that you people are going to ask me this. Read it. When there is no conclusion between two terms, then any relation could be possible between the two terms. Watch it now. Okay. Like I give you an example. Some A are B, some B are C. Do you have any conclusion between A and C? Can you get any conclusion between A and C? Please tell me. Some, no main conclusion. Correct? Right? So you don't know how many A are C because there is no conclusion. So it means any relation is possible between A and C. The possibility statement, all A may be C. You might get such kind of a statement, all A may be C. Correct? All A are C is a possibility. So both are same. All A may be C can also be written as all A are C is a possibility. Now your doubt must be resolved. And there are 8 possibilities, 2 combination for each of the 4 quantifiers. All A may be C, all C may be A, some A may be C, some C may be A, no A may be C, no C may be A, some A may not be C, some C may not be A. Get it? So when you do not have any conclusion between A and C, anything is possible. With respect to certain words being used like may not. Okay. So some A may be C, some A may not be C. Who knows? Right? So it can happen, right? So that becomes a conclusion. No, Chitturi, wrong. May or may not can always be true. Chitturi, did I say that? Why do you feel that I have missed on something? I haven't. And again, you're coming up with your own logic. No, sir, it is incorrect. Only when there is no conclusion between two terms, let us say A and C here, only when there is no conclusion between two terms, only then we can say may or may not be statements will be true. Okay, let me just write it for you, sir. Now it's clear, sir. Yes, Nagendran. That you can say. If no conclusion between two terms, if there is no conclusion between two terms, and we attach the two terms by using the word may or may not be, then it is true. Are we clear? Tell me which conclusions are correct. Which conclusions are correct? There is no option. These are conclusions. Options I have not given. All 4 are correct. What are you talking, Arvit? You don't see any difference between some A are C and some A may be C. Yes, Sanjay. Good. Now I'm seeing you. Come on, guys. All A are B, some B are C. So no conclusion exists between A and C. Okay. Hence, some A may be C, some A may not be C. Some A are C is definitive statement. Can you say for sure? No. Some A are not C for sure. Can you say as a conclusion? No. So 2 and 4 are possibilities, hence correct. Okay. So nothing can be said for sure between A and C. Pata nahi, don't know. Okay, that's how it goes. So let us say that there are two men. Okay, you find that you're driving a car and then you find two men standing at a let us say a bus stop. How are they related? Do you know? Do you know how they are related? No. What are the possibilities? Maybe they are brothers, maybe they are friends, maybe they are father and son. Okay, maybe they are grandfather and grandson, maybe they are brothers in law, or maybe they are not related to each other at all. Anything is possible. When you don't know exactly what is the relation between them, then all possibilities arise. Okay. All right, sir. How many questions? I think this must be the last one, I believe. Okay. Second, third. All right. Here we go. Right on time. I think I should be able to cover it in the next 30 minutes. Oh, this is the easiest of all the questions. I should give you a poll for this. Okay, just let me read. Fast, please. Tell me your answer, Garvit. It's like some game. Fill in the poll. Easiest of all, right? And was CSAT 2021. 69%. That is an improvement. So two statements, you directly go to the statements. Sum, whatever. Between greens and blacks. Blues is the middle term. So between greens and blacks, you cannot have a conclusion. Some greens are blacks? No. No green is black? No. All greens are black? No. All blacks are green? No. That's it. Hardly 30 seconds it should take, not more than that. Never, Sarita. Lots of mistakes. Please don't. And it has most of the questions from SSC. It is not to be used, it is full of mistakes. Okay, because I have solved almost the complete book. No. Chitturi, such kind of questions would never be asked. There is no question. A question cannot be formed of this frame that you're telling me. You can't have two statements like all A or B, all A or B. What is the conclusion? All A or B. How can you? No. You need three terms, sir. You need three terms. I should give you a poll for this, right? Are we ready? Thank you, Snehata. Here we go. So tell me the answer, Garvit. Very good, Sakshi. Very good, Gayatri. Yes, Garvit. Yes, Anushka. Yes, Amit. Yes, Abhijit. You think right. Yes, Samantra. Yes, Deep Shikha. Samantare. I hope I'm pronouncing your name correctly. What? Re? All cats are dogs. All cats are black. Huh? All and all. What do you get? All or some? All is tick cross. Some is cross cross. Dogs is getting cross. Black is getting cross. Cats is anyhow getting two ticks. So all good. So here your answer should be some dogs are black. Okay, and some black are dogs. All dogs are black. No, 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 no. It has to be in terms of some. So wrong. Some dogs are not black. No, 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 no. Some dogs are black. So wrong. So C is the answer. Over. Abhishek. Abhishek. Beta, how can it be A? All dogs are black. The see, you have not used the stick and tick, cross and cross, right? So here we have cross cross, no, for some. So your answer has to be in terms of some. How can it be in terms of all? All right, guys. Last question of the day. So what? Chandrasekhar, have already discussed with you. Chandra, okay, guys, I'm just taking you back because some of you might be having this in your mind. Chandra, do you see this? All plus all is sum directly. Huh? See, have you seen this? All A are B, all B A are C, some B are C. From all and all, you are getting some. We've discussed this, beta. Revise, it will register properly into your mind. You might be missing on certain things now, but if you revise properly, then you'll get it correct. Don't worry. See, this seaside guy is an animal lover. He has nothing, no other terms to frame the question apart from rats, cats, dogs, cows, almiras, table, chair. This is his level. Huh? Should I give you the poll? Take a good look. No, 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 Namrata. I never said that. Conclusion can't be a no. I never said that, Namrata. Why is that confusion in you? क्या हुआ बेटा? No, no, you will get it. You'll get it. So many things you're doing for the first time, so you need some time to absorb it. It takes time to sink in. All right, but try to do as much as possible with whatever you remember in this class. Later on, anyhow, you will revise, and when you solve questions, then you'll get it. Good. Good, Anushka. And Anushka. Anushka and Anushka. Both correct. Yes, Akshita. Yes, Akash. Yes, Kamlesh. 50%. Okay, sir. Three statements, so go directly to the conclusions. I told you that. No, cow is cat. Now here, this is where I have cow. Cow. And this is where I have cat. Dog is the middle term. No need for tick cross. Okay. Just tell me some and no. What is some and no? What does some and no result in? Some not. So can I have it in terms of no? No. It has to be some not. Some cats are not cow. So it has to be some cats are not cows. Similarly, we have no dog is a rat. Okay. This is dog. This is rat. To combine these two, we have cats as the common term. But then these are some. Okay. So some and some, you people know two sums. Give you no conclusion over. See? So can't have any conclusion between dog and rat. Third is some cats are rats. Watch it, guys. Watch it. Some cats are rats. Cats, rats. Cats, rats. So basically, this is an IC derived, IC derived from statement 1. Now you see how you need to use ICs and all. How do you need to check for ICs and MCs, right? So cats and rats are already present in one statement, no? So some rats are cats, swap. Some cats are rats. Absolutely fine. This is cool. So choice C is the answer. Very good. Thank you, Karthik. Very good. I'm coming to that, Jhansi. Especially when you go to although it has never been asked in CSAT, but if you go to RS Agarwal, then you will find that there would be questions like this. Now, please listen to me carefully. Some A are B, some B are C. So conclusions are given to you. Watch it, guys. Watch it. Watch it. Some A are C. No A is C. All A are C. All C are A. Okay. I'm just framing a question here. So which out of these are correct? Only 3 and 4. Either 1 or 2 follows. Then only 1 and 3. Only 1, 3 and 4. There is no conclusion is fine, but look at the choices that I have given to you, A, B, C, D. Now listen to me, guys. Listen to me very carefully. Listen to me very, very carefully. Now you know between A and C, you can't have a conclusion. Why? Some, no conclusion. So no conclusion between A and C. Now, if A and C are written in one statement along with some, and in another statement along with no, then these two statements form either or case. Now see, how many A's are C? We don't know. There's no conclusion between A and C. So what is the possibility? Either at least one A is C or no A is C. Correct? Either there would be at least one A which will be C, or there will not be any A, zero A which will be C. Yes? Huh? Correct or not? So here, according to the choices, if at all the choice has either or statement, then you have to mark B here. So please know this, that either or cases are formed between some and no and between all and some not. All right. These form complementary pairs. All right. That is either or pairs. Why? They're opposites, no? See, what is some? Cross, cross. What is no? Tick, tick. What is all? Tick, cross. What is some not? Opposite. Cross, tick. Okay. So these, if at all you get initial questions, it will be present in RS Agarwal. So some and no are either or, and all and some not are also either or. नहीं आ सकता थर्ड. ऑल ए आर सी है तो ऑल सम ए आर नॉट सी भी तो होना चाहिए मेरे दोस्त. वेयर इज सम ए आर नॉट सी? Both should be there, no? Here both are there. Some A are C or no A is C. Either one or two. Huh? Okay. All right. All clear? So please, please, please do practice, 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 revise and practice. Good night. Sweet dreams. All the best. Please do revise. Practice, practice, practice. Be confident. Believe in yourself. You're going to become an officer. All right. With that, Kapil Datta signing off here. God bless you.